Hello grade 5s, welcome to day 4, our last day together for math this week. Today we're going to be reviewing some of the same things we've been working on all week, but we're going to be looking at patterns within tables. Today you're going to be looking at tables that are called X and Y, and we're going to be looking for the pattern rule that we can apply by asking ourselves, what are we doing to the number that represents X to get to the number that represents Y? The first thing you're going to want to do is to identify if it is an increasing pattern, so it's getting bigger, or a decreasing pattern, meaning it's getting smaller. This is going to help you determine which operation it is that you need to use. If it's an increasing pattern, we can use the operation addition or multiplication. If the pattern is getting smaller and a decreasing pattern, we're going to either subtract or divide. Let's look at this example here. So if x is 5, we're doing something to it and it's going to become 10. So because it is getting bigger, it's an increasing pattern. So we're either going to add or we are going to multiply. So if I multiply 5 times 2 is 10. This pattern rule, should then apply to the next number. Is 6 times 2 11? No. So times 2 does not work. So for this pattern, I cannot multiply. So I will have to add. What do you add to 5 to make 10? I can add 5. Let's see if that rule applies. Again, is 6 plus 5 11? Yes. Let's check on the other number we know. Is 8 plus 5 13? Yes, so I should be able to apply this rule to find the missing number. 7 plus 5 is 12. So my pattern rule is to add 5, and I can write that with a variable. So n plus 5. Whatever number is x, I will plus 5 or add 5 to get the y value. Let's look at another example together. Okay, so x is 2, y is 10. If I start at 3, I end up with 15. I start at 4, I end up with 20. I start at 5, I end up with 25. First, I want to ask myself if this is an increasing or decreasing pattern. It is, again, an increasing pattern because the number I'm starting with, I'm doing something to it, and I'm ending up with a larger number. So I'm going to be looking at adding or multiplying. So I ask myself, what do I do to 2 to get to 10? Well, I can add 8. 2 plus 8 is 10. Is 3 plus 8 15? No. So that does not work. Plus 8 doesn't work. So the addition is not working. Let's look at multiplication. 2 times what is 10? 2 times 5 is 10. Is 3 times 5 15? Yes. Is 4 times 5 20? Yes. Is 5 times 5 25? Why, yes it is. So what is our pattern rule? A number times 5, or you can write it the algebraic way where you attach the variable to the number, 5n. So that is our pattern rule. So whatever number we start with, y I will find by multiplying by 5. So for example, if I was to start with 10, if 10 was the x value, I would multiply by 5. 10 times 5 is 50. So basically I'm just replacing this n with the 10. Let's look at some of the examples of the work that you will be doing today. You're going to have some task cards that look like this, a variety of them, and you are going to have different questions. For example, it says identify the operation performed on x to get to y. So you have 28 to 22, 27 to 21, 26 to 20. This is a decreasing pattern, so that means my options are to subtract or divide. I'm going to start with subtraction. 28 to 22 it's minus 6. I'm taking 6 away. Is 27 minus 6 21? Yes. Is 26 minus 6 20? Yep. So my pattern rule is a number minus 6. So I write it with a variable. Let's look at the one that says 23. It says write the rule for each pattern and identify which number completes the sequence. So 3, 12, 30, 39. The numbers are increasing. The pattern rule is getting bigger. So it's either going to be addition or multiplication. So let's first look at the first two numbers, 3 to 12. Well, I can times by 4. Now I'm going to look at the next two. Is 30 times 4 39? Definitely not. So the multiplication doesn't work. So I can try adding. 3 plus what is 12? I could add 9. Is 30 plus 9 39? Yes. So I can find this missing number by adding 9 to 12, and that would give me 21. Even though it's not asking you to, we would like you to write a pattern rule using a variable. So my pattern will be a number plus 9. Oops. So just somewhere on the card I can put the pattern rule. The other pattern rule you might look at looks similar to the examples we did together. Find the missing number, and then we'd also like you to write a pattern rule, next to the table wherever you can find space. So I'm starting with 3, then I have 12. I'm starting with 4, and then I have 16. So it's an increasing pattern. What could I add to 3 to get to 12? Oh, we just did that one. It was plus 9. Then I can ask myself, is 4 plus 9 16? No, so that doesn't work. So now I can look at multiplication. 3 times what is 12? 3 times 4 is 12. Is 4 times 4, 16? Yes, it is. So I can apply the same thing to find my missing number. 5 times 4 is 20. So my pattern rule is to times by 4, so I can write n times 4 or 4 times n like that, or I can write it the algebraic way where I attach the variable to the number. You may also notice that you see pattern rules within the table. So for example, the numbers in X are just going up by 1, 3, 4, 5, 6. The numbers in Y are going up by 4, 12, 16, 20, 24, which is the same number you're multiplying by. So while you're doing your work today, even though there's not a space for each one, please write a pattern rule using a variable. Have a nice day.